Okay, we're gonna see today, well, in this video, how to write two-column proofs. We're gonna use the inference rules that we studied before. Okay, so let's begin. Okay, in this exercise, they asked me to prove letter P. Like basically, I need to find out that P is actually true. And the premises that they give me is negation of Q and negation of Q then P. Those are the things that I already know. With those things I need to prove that P is true. Okay, so how we're gonna begin? Okay, we're gonna begin by writing the word prove. Okay, so make sure you do that. Okay, so like that's how we begin. I'm gonna mark that thing like this way. Okay, once you do that, then the person who's gonna check your proof is gonna know that, oh, okay, the proof starts here. Okay, and we're gonna work. The title of the proofs is basically the type of proofs we're writing as two columns, so we're gonna work in two columns. Okay, one column we're gonna use it to say all of the things we want to argument. Okay, all of our arguments. And on the other column we're gonna put our justifications, because all of the things that we say, they need to be justified. So picture yourself like if you were in front of lots of scientists, like in the old days. If you watch like some fantasy movies or stuff like that, imagine that you're in front of lots of wizards and you're gonna explain something new about the magic theory or something like that. They have a lot of tomatoes, so if you cannot justify your arguments properly, they're gonna throw you all of those tomatoes. So you need to be careful. Okay, all of the things that you say, they need to be perfectly justified. Okay, how are we gonna justify them? If something that we mention in here is a premise, then you're just gonna have to say given. Like you're gonna tell like the audience, like it's given, we know it's a premise, so it's basically given, we all know it's true. And the audience, all of the wizards are gonna be like, oh yeah, you're right, it's on the premises, yes, you're totally right. But if we try to say something that it's not in the premises, like an argument of our own, we need to justify using the rules of inference. Okay, and we need to justify like I'm gonna use like the adjunction rule of inference, but I need to explain whether do I have the requisites, if I fulfill them or not. So to do that, we're gonna have to quote some of our previous steps to do it. Okay, so let's begin. You're gonna understand once we start working with this thing. Okay, so how am I gonna begin this this exercise? I'm gonna begin by, well, basically I'm gonna start with this premise. I'm gonna put it in here. That's the first thing I'm gonna tell them. Okay, I'm gonna say, okay, negation of Q then P. Okay, I have this conditional. They're gonna say like, how can you tell that you have that condition? Because that conditional is given. Okay, so they're gonna be like, oh, okay, yes, it's given, you're right, I can see it on the premises. Okay, then I'm gonna continue with the other one, and I'm also gonna say, okay, this thing, I know that Q is not true. Okay, I have the negation of Q. And they're gonna tell me like, how do you know that? Oh, okay, because it's given. It's also given. It's on the premises. Oh, okay, it's on the premises. Nice. Okay. Now with these two things, if you notice, I have a conditional and I have the first part of the conditional. That's basically ponendo ponens. I have a conditional and I have the first part, so I can conclude the second part. So what I'm gonna do is I'm gonna conclude P. Okay, they're gonna tell me like, oh, how can you say that? How can you say that P is true? Okay, let me explain you. Okay, P is true because I used ponendo ponens. And but where do you use ponendo ponens? Okay, I use ponendo ponens on steps 1 and step 2. Okay, they're gonna check and they're gonna be like, oh yeah, you can use ponendo ponens there. Okay, so once I do that, basically I'm done, because I already proved that P is true, and that's what I was looking for, right? So every time you finish two-column proof, you're gonna have to put this this square box with an X on it, and that basically tells everybody that you finished and you did it. It's kind of like you you already proved it, so you kind of like raise your hands and you say like, and that's everything I had to prove. And all of the wizards on the audience are like, oh wow, awesome, cool, yeah, you did it. Yeah, so basically that's it. So let's try solving more exercises. Okay, this was kind of like simple. Let's continue with another one that will be kind of like in the same way. Okay, so I'm gonna use this information for the second exercise. Okay, so in this one they are asking me to prove negation of P. Okay, and they give me these premises. So as usual, I'm gonna begin with the premises, right? So I'm gonna copy like this one. If someone's asking me like, why are you copying the second one first, you do it on your own convenience. Okay, I know that this, well, I want to do it this way, and also like for me it's convenient because it's gonna look like identical to one of the rules that we're gonna work with. Okay, so the first one is given. The second thing that I say, it's also given. Okay, so they're gonna be like, oh, okay, yes, this is given, I can see it on the premises. This is also given, yes, I can see it on the premises. And if you notice, I have a conditional and the opposite of the second one. That will be tollend the tollens. If you have a conditional and the opposite of the second one, then you can copy the opposite of the first one. Okay, so I'm gonna conclude with the opposite of P. And they're gonna be like saying, like, the audience is gonna say like, but how can you say that? And I'm gonna be like, okay, relax. Look, I can say that because if you use tollendo tollens on steps 1 and 2, you can conclude that, and they're gonna check and they're gonna be like, yeah, if I use tollendo tollens, yes, you will get this. Oh, okay, yeah, you're absolutely right. Okay, and I'm like, okay, I finished, I proved it, so thank you very much. And then we have the applauses, right? Like, oh yeah, he did it. Okay. Okay, so let's do another one. Okay, if you realize it's kind of simple, you write your arguments. Okay, whether copying the premises or saying something you want to say, but you always need to justify. Like all of the stuff that you say, they need to be either given or explained with an inference rule. Okay, so we use this inference rules. We need to make sure that we fulfill the requisites for doing so. Okay, let's see. Yes. So, okay. So let's do another one. Okay. This one is, yes. Okay. So if you heard the voices on the back, there's a special kid on the house, so like we're taking care of him. So okay. Now let's see this other exercise. We're looking for P. Okay, we're trying to prove P, and they give us these premises. Okay, so what are we gonna do? Something that's very helpful is to try to think like backwards. Like, I'm looking for P, so where on the premises can I find P? Okay, I have P in here, but it's the opposite, right? So how could I get normal P? Well, normal P will be the opposite, so I can get the opposite using tollendo tollens. So for tollendo tollens, I would need the opposite of Q. Where do I get the opposite of Q? Okay, I get it with the first premise. Okay, but for getting the opposite of Q, I need S. Do I have S? Yes, I have S on the third premise. Okay, so now I know what I have to do. I'm gonna use A and C to get negation of Q, and then I'm gonna use B with the negation of Q to get P. Okay, let's see. Okay, so I'm gonna begin with A. Okay, so I have S, then negation of Q. And they're gonna say like, how can you say that? Oh, because it's given. Okay, it's given, so it's already there. Now, I also know that S is true, and if you ask me like, how do you know that S is true? Because that's also given. That's also on the premises, so it's given, and no problem. Okay, it's given. Okay, now, with that, I can conclude that Q is not true, negation of Q. How can you say that? Well, if you take a look on steps 1 and 2, if you notice, I have a conditional and I have the first part of the conditional. So ponendo pones tells me if I have a conditional and I have the first part, I can copy the second part. Exactly the same. Okay, so I'm gonna copy negation of Q exactly the same. That will be ponendo ponens on steps 1 and 2. Okay. Okay, now that I have negation of Q, I'm gonna copy this conditional. Okay, and I'm gonna say that this thing is true, but then you're gonna ask me, like, how can you tell me that that thing is true? Justify it. Okay, I can justify by saying that it's given on the premises, so no problem. Now if you focus in here, I have a conditional and I have the opposite of the second part, right? Yes? If you notice on tollendo tollens, you have a conditional and the opposite of the second part. What happens when you have the opposite of the second part? You're gonna copy the opposite of the first part. Okay, so I'm gonna copy the opposite of the first part. The first part is negation of P. What will be the opposite of negation of P? Normal P. Normal P is the opposite of negation of P. Now how can you say that? Okay, I just explained it. I used tollendo tollens with steps. I'm gonna like try to say 4 and 3. You could say 3 and 4, it doesn't matter. Okay, kind of like have a way of trying to put the requisites in order, but that's kind of like my thing. Okay, like you can put like 3 and 4 like a normal person does. Okay, and now I have P, and if you might think like, what do I do next? Well, you don't do anything next because you already found P. Okay, so you just have to tell the audience that you finished, that you did it successfully, you finished the proof. So you put the box with the X. Let's try doing another one. Okay, let's try and doing this one. It looks kind of like a little bit difficult. Okay, so my goal in this case is not finding P. I'm trying to find letter Y, statement Y. Okay, and they give me this premises. Okay, so what do I have to do in this case? This is not like you already know from start what do you have to do. You need to think a little bit. Okay, that's why I kind of like try to use like a backwards analysis. Okay, Socratic analysis, some people call it. Okay, you want Y, so which ones of the premises are going to give you Y? A, right? Okay, but this is negation of Y. To get the opposite, you have to use tollendo tollens. But for tollendo tollens, you need the opposite of the second one. So you need positive P. Where do you get positive P? With the premise B. Okay, with the second premise, you can get P if you have Q, but you don't have Q. How could you get Q? With the third one. With the third one, I could get Q if I had this ones. Okay, X or N. Okay, do I have X or N? No, but I have X. So let's begin with that. Okay, I have X. Okay, so let's put that I have X. Okay, how do you know that you have X? Because it's given. It's given on the premises, so I do know that I have X. Okay, no problem, it's given. Okay, now with X, I could get this part, X or N. Okay, now you're gonna tell me like, wait a second, how can you get N if you don't have N? Okay, N is not even on the exercise, it's only on the third premise. So where do I get the M from? I get it from my own head, from my imagination. I'm gonna use the rule of inference that's called addition. Addition tells me that if I have something, I can put an OR, and I could put whatever I want. And I want to put N, so I'm gonna put an OR, and I'm gonna put N. So what's the what's the rule of inference that I used? I used addition. Addition at step 1, right? So I have no problem because I justified that I used addition at step 1. Okay, now that I have XOR I can copy this one because now I can use ponendo ponens. If you notice, like, you need to get really familiar with the rules of inference. You need to know these ones, like, in your head. They need to be like, they kind of like need to give you like a click so that you can know what to do. Okay? With practice, you kind of like get that thing. Okay. I'm gonna put the conditional, but how can I tell that the conditional is true? Because it's given. Okay. It's given on the premises is the third one, so no problem if I put it on the process. Okay. Okay. Now, I have a conditional and I have the first part. That will be ponendo ponens. I have a conditional and I have the first part. So what happens if you have the first part? I can copy the second one. So I have the first part, I can copy the second part alone. Okay? And what is that? That is ponendo ponens with steps 2 and 3. Okay? But I kind of like have a thingy. I'm writing like the requisites in order. That's my thing. Okay, you can put 2 and 3 and there's no problem with that. Okay. Now that I have Q, I can use Q with the second premise to get P. So I'm gonna copy the second premise, like, because I don't have it in my process, I need to have it in order to do that. So I'm gonna copy this, and how can I put that in the process? Okay, I can put it because it's given. It's given on the premises, so I can use it whenever I want because it's given. Now I have a conditional and I have the first part. You should already know what to do because we just did it. I had a conditional and I have the first part. So what do we have to do? We need to copy the second part. If you check ponendo ponens, if you have a conditional and you have the first part, you can copy the second part. So I'm gonna copy the second part because I have the first part. So I'm gonna copy P. And how can I justify that? I can justify it with ponendo ponens using steps 5 and 4. Why do I put them this way? Because I want to put the requisites in order. If you see, the first requisite is the conditional and the second one is like, okay, here the first one's the conditional, the second one is the one that's alone. So I do that, but you don't have to do that. You can put 4 on and 5 like a normal person. Okay. So now that I have P, if you check on the premises, I have P, and P is the opposite of the second one. That will give me the opposite of the first one. If you know which inference rule is that one, congratulations, you're kind of like getting used to it. If you don't worry about it. Okay. I'm gonna put this conditional. How can I justify that I can put that? Because it's given. If it's given, you can use it on any moment. Okay. Now I have the conditional and I have the opposite of the second one. If I have the opposite of the second one, I could get the opposite of the first one. How can you tell that? Okay, that is tollendo tollens. I have a conditional here, and if I have the opposite of the second one, then I can put the opposite of the first one. Some people might say like, yeah, but this one is negative, or like it's a negation, and this one is not a negation. It doesn't matter. The idea of tollendo tollens, you don't even need to have P and Q. It could be like any other letter, any combination, but the processing here, the explanation is you have a conditional and you have the opposite of the second one. That gives you the right of just placing the opposite of the first one. So I have a conditional, I have the opposite of the second one, so I'm gonna put the opposite of the first one. If you're like, why is this dude repeating it so many times? Because I'm explaining it like for people like who's maybe trying to do this for the first or second time, so I'm kind of like emphasizing. Okay, which rule is this one? Tollendo tollens. And which steps did I use? I used steps 6 and 7 because I have like an issue with myself. I'm gonna put 7 and 6. Okay, Now I have letter Y, the statement Y, and that's what I was trying to prove. So I'm done. Okay. So how can you explain the audience that you finished? You explain that thing with the square box and the X. Okay. So that will be like the proof for this other example. Okay. Let's do one more and that's it. Yeah, I know it's kind of long in the process. If you kind of like got the idea, like you don't need to work about the other examples, but this one is with the Morgan's law, so like to practice a little bit the Morgan's law. Okay, so let's see. Okay. I have this premises and I am trying to prove P. Okay, so how could you get P? I get P with the second premise. Like if I had negation of Q, then I could get P, but I don't have negation of Q. I have this weird thing. It's the only thing that I have. Like I cannot use the conditional yet, but I do have this, so I'm gonna use that. Okay, I'm gonna copy it in here. I'm gonna start with that. How can I justify using this thing in my process? Don't forget to put proof. Okay, always put proof before you begin the solution. Okay, so let's see. This thing is given. That's the reason why I can put it in the process. Now, do you notice that you have a negation outside and there's kind of like a parenthesis and an or inside? We're gonna use the Morgan's law. The Morgan's law is kind of like using distributive property and changing, like flipping. Instead of or you put and, instead of and you put or, but you use distributive with the negation. You kind of like flip the signs of everything. That's the idea of the Morgan's laws. So I'm gonna put negation of Q. This is an or, but remember you need to flip when you're using the Morgan's laws. So I flip it to an and then I'm gonna put negation of R. If I had a negation inside, then the negation of a negation would be like a normal letter, right? So yes, that's what I get. And if you're asking me, like if somebody asks me like why did you do that? I did that because I used the Morgan's law. Okay, the Morgan's law at step 1. Yeah. Okay. Now I still need negation of Q to get P. I don't have negation of Q. I have negation of Q and negation of R. The important thing here is that I have an and. Like what happens when you have an and? You can use simplification. Simplification tells you that if you have two things with and, you can copy only one of them, and that's okay. Okay, like I could copy the first one or I could copy the second one. I copy the one I want. In this case, I want negation of Q because it's what I need to get P. So I'm gonna put negation of Q. Okay. And how can I justify like just putting negation of Q? Because that's a simplification. Simplification at 2. Okay. Or you could, some people say simplifying step 2. Okay. It's also okay. Like you kind of like, as long as it can be understood, you can justify in those ways. Okay. Now that I have the negation of Q, I can copy the conditional so that I can use ponend opponents. Okay. Why am I gonna use ponend opponents? Because ponend opponents is the one that if you have a conditional and you have the first part, you can copy the second part, and that's basically what I'm looking for, the second part. So I copy the conditional. How can I justify that I have the right of copying that conditional in my process? Because it's given on the premises. If it's a premise, you can use it on any moment. Okay. Now I have a conditional and I have the first part, so I'm gonna copy the second part. That's ponend opponents. If you check ponend opponents, you have a conditional, you have the first part, so you can copy the second part. Okay, so I'm gonna copy the second part, P. How can I justify that? I just said it. It's ponendo ponens. And which steps? Step 3 and step 4. Okay, because I like doing things like backwards. I put step 4 and step 3. Okay. Now I have P already, so I proved P, so that's kind of like it. So all I need to do now is put the square box, okay, to finish the exercise. What does the square box mean? The square box means quodera demonstrantum, which is a Latin expression for, and this is how I finished, something like that, and this is how I proved what I was trying to prove. Okay, the thing we were trying to prove has been proven by me, something like that. Okay, so that's kind of like the idea. You work with steps, you work with either given to explain that you have a premise, or you quote any of the inference rules that you need to use, and you explain like where on which steps you know that the requisites are fulfilled, so that you can use actually the rule of inference. You can only use the rules when you fulfill the requisites. Remember that. And basically that's it. Now never forget to put proof at the beginning and the square box with the x at the end. If you don't do that, you're kind of like messing with things, because the proof tells you that you're gonna prove everything in here. So like all of the things that you put here are gonna have to be justified and so on. And this square box is kind of like a finish, kind of like if you're writing a program, like if you're programming, like here this tells you like the programming begins, and this is kind of like the end line of the programming code, something like that. So basically that's it. That's how we write two column proofs.